welcome to this podcast episode, which is about, I would say, innovation and entrepreneurship. And here we have Jonas,
Yep.
who invented this amazing machine. And I just want to give a bit of background on because for me, roasting education and roasting technology has always been outside Denmark. So for me, Denmark has never been an area of interest for my business or for anything fun, really, other than all the amazing coffee shops we have here in the great community. But coffee roasting geekiness was something that I kind of found outside Denmark mostly.
Yeah.
So a lot of things has changed the last couple of years for the better, for sure. And you coming a bit back to Denmark is for sure for me one of those. But I just want to give a bit of background in that. I think I heard, when was it that you established the community here in Denmark?
Denmark, that was
around Bønneklubben.
Bønneklubben.
Yeah, or your.
Well, I started the company Aillio in 2013.
Okay.
In Taiwan, but that was more to get myself a visa so that I could live there.
Okay.
While I was working on developing the roaster itself.
Okay.
So the company has existed since 13.
Okay.
But I would say 2.5 years after that, I started to publish some stuff online on the forums. There's a home roasting forum. Yeah. There's a home roasting forum. There's some American forums talking about, small batch roasting. So I started to make some posts on there, and from that point on, pretty quickly there were some Danes who got involved.
And that's where I heard about it in the first place, and I remember.
So you've heard about it for a while already.
Yeah, I've heard about it for a while, and even I borrowed one from Jon when I had a problem with one of my, because what I've done this far has been roasting on big machines and pilot roasters.
Yeah.
So I've got the Probatino and I've got the CoffeeTech FZ94. I've had them for many years. Now I have much more. I have Stronghold, I have Loring, and so on, and Ikawa as well, and obviously the Bullet. But that goes without saying. So for me, it's been professional. That has been my whole focus always. Never. I've seen the Hot Top and the Genio and all those, they were fun, Yeah. So when I had a problem with having too many people on my course, I found out that Jon had a Bullet. So I got it, and we did used it for a course, and I thought that's okay. But since my focus was professional, I never really kind of. Never really understood it in the way that I do now. Yeah. So that's just to give you a bit of background. This might have been 2017-ish or something like that.
But that's typical as well.
Yeah.
A lot of people, they think it's just like a home roaster.
Yeah.
They actually don't have any idea about how it's constructed or how it really works.
Yeah.
So I think many people had the same perception as you that, even some people, they told me, I thought it was built made by plastic. And then once you understand that it's actually like all stainless steel configuration and a big heavy metal drum inside, then they have a different idea about the machine. Definitely. And then they take it a bit more seriously as well.
Yeah. And this is where I've been kind of through a transition now the last year in many iterations and. The first step, now I'm just giving you my kind of experience and giving it to the listeners, and then we can go into the more, I'd like to get some of your background as well, but just to get a bit of history here. So I got the Bullet, I think, is it a year ago or something like that?
Yeah.
And to get some more hands-on, because I've just heard more and more about it, and I thought this actually looks like an amazing machine. And then my first kind of challenge was I just really wanted to try to roast 200 grams. And I spent a day and I never succeeded.
Okay.
And that annoyed me, and I thought, okay, now I'll go 1 kilo. And not having succeeded with 200 grams, I was a bit, it's induction, and I really got some burn marks on the beans, and I thought, it's induction, and that must really create a hot drum. And I was convinced. I after have been working a few days, I thought, okay, the software is amazing, and the machine is really. It seems like amazing quality, but if it can't really roast coffee,
what's
then
the point?
then yeah. So then after a day where I wasn't too convinced about what came out with the 200 grams, I then went to the 1 kilo and so full batch.
Yeah.
And that's really challenging because it's only 1500 watts. So I didn't expect. So the first thing I do is always full batch and then see how fast it can go.
Okay.
That's always the first thing I do when I consult and if they allow me to do, because this tells me so much about the roaster
itself,
how to handle it in the future. Basically, it's like jumping into a car, step on it.
Yeah.
If it then it tells you something, and if you it's like being kicked by a mule.
Yeah.
Then you know, right? That's a fundamental thing you need to know. So I did that, and I got really fast speeds, and I thought, ooh. And particularly if you want to roast Scandinavian roast, you want speed, right?
Fast.
So we did a bit of a challenge, me and my good friend Reza, and we took what we consider to be a really challenging task, which is making a light roast Kenya, right?
Of course, yeah.
That if that works, we are good.
Yeah.
And we did a lot of experiments together on the different machines. And I have a lot of brands, and I love all of them, and I love all roasters, so I'm not picking out favorites. And this experiment might have been able to come out differently if we did things in different ways on all roasters.
Yeah.
But the Bullet came out as everybody's favorite. One of the 5 experiments we've done, and we did a lot of them. So, of course, we could have done a lot of different. So it might have been, the first page could have been a bit fluent, but I completely forgot about any reservation, right?
About the 200 gram.
Exactly. So I just thought, all right, there's no limitation.
Yeah.
So I kind of, at that point, I just got it. And now I see Rob has done some amazing work on small bets, and I'm really happy to see that. So
the new article that came out last month.
Yeah, that's
fantastic.
Great. He obviously he knows what he's doing. So I haven't applied his principles yet, but it's great work what he's done. So he might have solved what I couldn't. I have to kind of live with that. That's okay. But that was just to give you kind of my first. I didn't really know about it. Then I learned about it. Saw the technicalities was amazing. But when I tasted that Kenyan, I was just, okay, that's great. Okay. Oh, and there's an extra element. I do a lot of professional courses, and you said that this is, some people consider it the gray zone between consumer and professional.
Yeah.
Where I've done a lot of professional courses, I mean, the SCA Roasting Professionals in Copenhagen, but also in Saudi, where we didn't have enough roasters, so we brought in some bullets. And not in Copenhagen, neither in Saudi, people were, we got the home machine. It's just, they saw the software and they just worked, and they got exactly the same experience as everybody else. Okay. So there's no nobody mentioned that it's anything than a proper professional pilot. And I think that's really a great kind of...
But I think that's the point. Once you get it in people's hands, once they start working with it, then they know much more what it is, right?
Yeah.
Because when we launched it, it was just an experiment. It started with an experiment. I'm from, my background is photography, and I had a studio in Hong Kong at the time because my parents were stationed there for a while. So we started serving coffee to our customers in the studio. Also, to give them the whole package, right? You have your great portfolio, you have your fancy studio, and then we started giving some nice coffees with some latte art, because this was not happening 15 years ago in Hong Kong at all. So
this is 2000. 12, 13 years.
14. What's that? 2010, I think. Or before 2010. Okay. Yeah, just before 2010. So, but I was also looking for a roaster, because at that time getting specialty coffee in Hong Kong was almost impossible. I think it was 2 or 3 roasters in Hong Kong at that time, and it was all espresso blend, right? There was no single origin or anything like that, so it was hard to get. So I got a Bemor first, just to do something, right, for myself. And my twin brother Jacob, who's now also involved in the company, he had the gene, because he and my dad, they bought the gene together to save money on fresh coffee, because they were tired of paying top dollar for that in Denmark. So they got one. They started roasting in Denmark, at the same time that I bought my Bemor in Hong Kong. But I you know, it didn't work out of the box. I had to replace like 2 or 3 PCBs. I mean, they were friendly. They got it working, and I used that for a bit. But I always thought that there was something, you know, you could do something a bit more between, you know, just the home roaster and the commercial roaster, right? So when we finally launched it, we purposely, in the beginning, we thought, should we say that it's a home roaster? But then we thought, why put a
label?
Why put a label on it, right? So we ended up saying it's just a 1 kilo roaster, and that turned out great because you had the home roasters buying it, especially the, you know, Brenneklubben, the bean club here in Denmark, which got involved pretty quickly, and then you had probably half of our customers are professionals, just like yourself, right? Using it for sampling or profiling or trying to take a small batch and bringing it to a bigger roaster. And I think a lot of people who came from, I mean, who are professional in roasting, they had the same problem as you. They had a hard time in the beginning figuring out, you know, how does this induction translate to a, you know, a big industrial gas roaster, right? But so it takes time, and I saw that even when we were developing the machine, we had a few guys in to test it, and they came from like 5, 10, 15 kilo probats, and it also took them like a day to figure out, you know, how, especially the fan speed, how does that translate to something on a bigger scale? So yeah, I think that's it's a common thing.
Yeah, but let's go back a bit. So also to ask a bit personally, why did you start a company, and why didn't you just get a job, right? Why take all this risk, create something that, because this doesn't. Normally, I think about starting a company. It's not a good idea.
No.
In a sense that a good idea is something that's obvious and easy, right?
No, it's not.
So getting the idea to build this at that price point that you can sell it at, if I didn't know you and so all this, I thought that I would really advise people not to do it,
for sure,
or even try. So why? So the first question is, why didn't you just look for a job? Why did you jump out and want to try to create anything really? So that's more a personal question. Why didn't you kind of fit into a job? And the next question is, why did you keep on developing? Why didn't you just give up at some point?
Well, I think even for my teens, I've been a little bit like I've been somewhat of a rebel. You know, even in my early teens when I had a job, because I was studying, right? But then I had these odd part-time jobs after work, and I always hated my boss. I never thought they were very good at, you know, managing people, or what they said most of the time didn't make any sense at all, right? So I started studying photography, and I think for that, photography is perfect because you usually end up as a freelancer. So that would work out, and that's what I did in Hong Kong for 10 years. I was freelancing as a photographer. So, you know, so that was also my own company over there. So I think, yeah, it's just in my nature to work independently at least.
But it's an interesting thing, and people, they often start a company because they don't like the boss.
Yeah.
And then they think they get freedom and time. But you get none of that.
Yeah.
Because now you're a slave of your own batch systems, and you don't even have an education in organizing and managing, right? Yeah. So how would you make it better than the boss that you didn't like, right?
Well, photography is easy because you're kind of like just yourself, right?
Yeah.
And as long as you get along with your clients and they like you, you're fine.
Yeah.
Right. But of course, you know, taking that and then building a company is completely different. And I think, I mean, in terms of the bullet, it was more like an experiment in the beginning, because when I started to do the research, I was just on all the forums, reading up on, you know, why is no one making a 1 kilo electric roaster? And then you get all the replies afterwards, which is like, it's not possible. Like,
so who did you ask? That was on the forums, you said.
I mean, just Googling, right? Just doing some your own research, and then you start making some posts like, you know, why is no one doing like a plug and play 1 kilo electric roaster? And then the reply is like, it's not possible. And when I studied before high school, my master was in physics as well, physics and math. So I can do, you know, basic calculations. It's not rocket science, right?
So that's gymnasia, right?
Gymnasia.
Yeah.
So I took the technical line on that.
Yeah.
So, I mean, when you read, first of all, if you have a hot tub, right, you roast 200 grams, 250 grams, and the whole thing on the outside gets so hot that you're burning yourself if you touch it. I mean, basic principle, if you could keep that energy in the machine, you should be able to roast more coffee, right? That's obvious. So first would be insulation. You insulate the machine, you should be able to roast a lot more. And no one was doing that. Even the hot tub, they just put this grill on it so that you can't touch it, right?
Yeah.
Instead of just, adding some insulation to it, which I thought was odd.
And the BMOR, there's a huge amount of air heated up for no reason, right?
Yeah. So that was the beginning. So, and then I was, and then I got all these vague arguments online that said it was not possible. I'm like, hang on a minute. I mean, at least if you insulate it, you should be able to get a lot more than just 200 or 250 grams. So then I started looking at, the power consumption of these machines, and then I thought, okay, where is this energy really going? Because on many of them, it's just going out, right? Like on the Gene Cafe, it's just hot air going out into the open. So I just thought to me, it just sounded not right. And then I started talking to my twin brother, who is an engineer. He's an electronics and mechanical engineer. So I started talking to him about it, and he's like, because he already had the gene, right? He knows there's a lot of mechanical aspect to a roaster and some electronic. He's like, just forget about it. This is not gonna fly. It's never gonna happen. Just spend your time on finding out what you really want to do with your life.
And that was the right thing to say to you.
Yeah, for sure. it was, because it made me think. Okay, and he's also like, if you don't have anything that's better than what's out there, I mean, if you just make a copy of a hot tub and you add insulation, I mean, there's nothing special, right? That's what the home roasters would be doing anyway. They'll be modding their machine so that you have, you can get the data that you want and you can roast more coffee on them. So that's nothing special. But then after like a few months, I came up with the idea of using induction for the heating. And then I explained that to him. And then he's like, okay, this is interesting now. At least you have some technology that no one else is having. So our hope was that with induction and with good insulation, you should be able to do probably double of what they did, the small home roasters. But then it turns out it's actually 4 times the amount.
Exactly, yeah.
So that's just pure luck.
Yeah, because the gene is 300 grams.
200, 250, yeah.
Yeah.
300 would take you 20 minutes.
Okay.
Yeah. So that was it. And also being able to just do that on a standard American plug. Because on a 120, you only have around 1,500 watts available.
So that's the constraint.
So that was a constraint.
Yeah, because we have more here in Europe.
In Europe, we have a lot more. So and we've also modded some of the bullets. So if you do it 2,400 watts, you can do a 1.2 kilo in 9 minutes.
Is that official now?
Yeah, that's what they're doing here.
Okay, yeah, I know. But I was just told it wasn't official.
It's not official,
but I guess it is now.
Well, yeah, it's possible for sure. But the idea is to keep it consistent with America, right? Because all the data we share on our Roast World platform, we also want that to be compatible with any market around the world.
Yeah.
So that's why we kept it at 1,500 watts.
Which is also important for me because I'm doing online live courses with people in the US and Europe. So I have always a mix of people with different voltage on the classes pretty often.
So that was the idea behind that. So.
And what kind of insulation do you have, and how thick is it? And now, if I'm asking about something that's intellectual property, just tell me.
Anyone could take it apart and take it out. So we have around 25 millimeters of ceramic. What's it called? Ceramic felt around the whole drum down to the electronics down to here. Obviously, at the top where you have the pipe, there's only some 3 millimeter ceramic on both sides of the pipe. Yeah. So that's also why the hottest part is at the top here. Yeah. But it's still very, very well insulated. And those insulation is something we buy from France. It's a very, very big, it's called Morgan Ceramics, because it's the only tested ceramic that is certified not to cause cancer. Okay. So because a lot of the other ones, they actually, the tiny glass particles will actually get stuck in your lungs for maybe up to a year before they get out, before they come out, which can cause cancer. But we use something that is scientifically proven not to do so, right? So because it's in a food product, so we want to make sure that everything is absolutely safe.
Yeah.
So, and then you have at the back here, you also have like 30 millimeters of insulation. Same material, just a different. It's just loose fibers in the back.
Yeah, and then the machine ends up being environmentally sustainable, right? And that was actually not really the point in the beginning, right? It was just to be able to make.
No, but for sure. I mean, if you can do 4 times the amount of a traditional heating element electric roaster, then you could say it's a green product. Right.
And in being in Europe, it's really great that it only uses 1500 volt, because then you can plug it everywhere.
Yeah.
Sometimes if it used just the complete fuse, right, then you would always don't turn that on or this on, so because then it would kind of blow the fuse, right?
Blow the fuse for
so you can just plug it anywhere and, without really worrying about it.
And 1500 watt is only if you're roasting a kilo, and it's only for maybe those 10 minutes. Because when you're preheating the machine or afterwards, it's not using.
Yeah, it's not using. It's only maximum. Yeah. So if you think about the journey from the early ideas and then until now, was there periods where we're just kind of almost giving up, or this is too much, or I don't have the?
Not really. I think. I mean, for me, it's been a journey on so many different levels actually. Because first of all, I thought I was going to miss photography, right? Because I've been doing that for 10 years, and it's a fun job. You're dealing with lots of people. You're dealing with models and all these creative people from the agencies and stuff. So I thought I was going to miss that. But at the same time, I was also really tired of like every time I wanted to make some money, I had to work.
Yeah.
Because even I had a studio with assistants. I could not ask my assistant to shoot for a client. They wanted me to do it, right? Because they wanted, my look in their pictures. So I was also looking for something that I could create, but then, it can grow bigger than myself, and I can keep selling it even when I'm not working. So I wanted to go from the service industry to a product. And I know a lot of people in the product industry, they want to go to services because they are tired of designing and manufacturing products, right? So I was going the other way. But I think a lot of things triggered. A lot of things did that I thought it was possible to create a product that really works. I mean, even from our first prototype, which I spent like 6 months to make, that was kind of the turning point. Because in the beginning, okay, sure, you think induction is going to be great, right? But you don't know like how hot can induction actually make, this size metallic drum, and is that going to be hot enough to roast coffee? So we did one basic prototype, which was, I didn't have money for a 3D printer, so I had to build my own 3D printer based on some drawings online, right? So I did that, and that was printing pretty shitty prints, but it worked. So I could design some legs. I went down to the local metal shop to bend some aluminum parts. I had a drum made, had some parts made in China, put it all together, and then I bought this little cooker, induction cooker hot tub, and I ripped the coil out of that, and I printed my own holder for that coil. I wound it up, and then I just got the drum turning with some simple DC motor, and it worked for one roast, right? After that, it just collapsed, and the legs were melted, the coil was melting, but it proved that you could.
It was a proof of concept.
And I think at that time we were roasting 600 gram for the first roast, and it did that in like 10 minutes. And it was only 1500 watts. So, and there was no insulation at all. The drum was just in the air turning. So after that, it proved that it works.
Yeah. But okay, but I just, in my mind, that's just a bit. Why were you so sure that it was even technically possible with no education to kind of show you the way? Or no other project where you did it already? Where did you get that certainty that it was just possible at all?
Well, what I've always been, I was not sure about anything until it was actually I had this down in my mind.
But you were sure enough to not stop trying.
Yeah, there's two aspects to this. I was sure that I could make a prototype work. That's one thing, okay. But how well it worked is another.
Yeah.
But then the second step after the prototype would be, how sure are you that you can bring a product to market?
That's
and those are completely different things, right?
Yeah.
So I think after the prototype worked, then of course I kept making more and better prototype, more assembly like this final product we have here, and that actually worked pretty well. They were very crude, like again some 3D printed part with some big sheets of metal just screwed together and glued with epoxy, and nothing, no customized parts, so I had to bend everything myself basically. But after those, after getting those to work, I knew that this is possible to use, right?
And
but
you had a different technology that was the reason why it worked in
the
first place.
Sure,
so now
sure.
it was a question about improving it.
Yeah, for sure.
So that's the technical part. Why were you sure that there was a market for it, even if the technical worked and you could make it mass production?
Because I could see from the replies online that people, they wanted it, because many people had asked the same question again and again. Why is no one making a 1 kilo electric roaster?
Which forums are these?
I forgot. Like the home roasting forum and the Gene Cafe. Lots of these smaller forums, they had people asking, and the reply was always the same. And that's also why I got intrigued, right? I thought this should be, it's at least better than 250 gram. And then it turned out that 1 kilo was actually possible. But I think for the getting the home, one thing is building a prototype, but actually getting a machine into production is just, I would say it's much more difficult than designing the machine. And that's what everyone told me from the beginning. It said, yeah, wait, you have a prototype, is working, good for you. Just wait until you have to start making 250 of these. Yeah. It's going to be hell. And I'm like, how hard can it be, right? You have the prototype.
It's a good thing not to have education and experience.
I was pretty naive, right? I thought, if you can make one, you can make 250. So turns out that they were somewhat right. It was very, very tough. And it's still tough today, actually. Still tough keeping consistent quality and sourcing parts and stuff. It's building products is extremely difficult, but most people don't know that. They just see the final product, right?
Yeah, but another thing to add to this, it's difficult not to make the prototype. It's difficult not to even get the production up and running. And you can, hopefully there's a market, but the fourth thing is another really weird thing is that you can make it work at that price point. Because it might not be a problem to make 200 units if you can sell each unit at 30,000 euros. Yeah. That's doable, right? But so the next weird constraint that kind of you've made work is at that price point. Well, that's difficult.
No, for sure. But when I started, because I talked to my friends about this, and I talked to my brother's engineering friends, and they said, well, look, just wait and see until you get, start going into production. So I knew I had to focus on, what they call made for manufacturing. Design for manufacturing. So try to design the product in the most simple form that is easy to manufacture. So even though I don't have an engineering background, like once I start building my 3D printer to make these prototypes, from that point on, I was already studying CAD design. I was studying product design.
In your spare time?
No, it's just full time, right? So I would just take an odd job on and off as a photographer, but I'll be doing this for like 100 hours per week.
Yeah, but I'll do it. Self-studied. It's not
self-studied. Yeah. It's just online studies, buying books, asking my brother, and he's like, okay, now you've done this, but you need to study tolerance trees. I'm like, okay, so I will study that, right? And then I would find out, okay, this, because what works in CAD doesn't work in real. And that's what people don't understand. They think you just design something and then it come out in that shape. But that's not true. Yeah. Like when we do precision CNC milling, you would think that it always comes out straight, but it doesn't. Milling this front plate, for example, is 4 millimeter thick, right? And you have to mill obviously the hole for the door and some other features. And you think if you have a good machine and you start milling, then it's always going to be the same, but it's not. So you got all these weird tolerances everywhere that you have to take into account before you can manufacture anything.
After you've made the perfect 3D model that would work.
Yeah. So and that's what you don't understand. You think, but they say they can do plus minus 0.001 millimeter. Yeah, that's technically possible, but it doesn't happen in real, right? So And of course, the finer tolerances you want, the more you pay for it as well. So it's really about manufacturing something that even with the worst tolerances is still going to fit, and it's still going to look nice, and it's still going to be functional, and it's still going to be able to be assembled easily as well. But that's only what you learn once you start manufacturing, right? Some parts just don't fit. Like our very first problem was that these hinges on the front of the door, they didn't fit, so the door wouldn't close all the way. It's like, wow, how come this happened? And then we found out then, well, some tolerances on the door were wrong, some of the hinges were wrong, so we have to, update our CAD design to allow for, bigger variations in tolerance, right? So I think that was a big learning curve there.
But you've just been determined all the way through and just kept on knocking everything down.
But I think even when we placed all these orders, when we bought the tools for the plastics, when we were making I think we did 21st, as I remember. Even at that point, I thought there's something that's going to come up, so this is not going to work. I thought there's something that we're missing that that might turn out to, maybe we can send out the 250, but there's going to be something wrong with them. Not so much in in the manufacturing process, but with the machine itself that is going to hurt us afterwards.
Yeah.
But that was not the case. I mean, right now we are working on the new machine Aillio, right? And we are testing it like crazy. This one, it was tested, but in terms of tested for how the coffee tastes, and sure, we did tons of roast on it, but we didn't have that many experts trying to roast on it and giving us feedback. And I think the fact that it roasts so nicely and that the taste is so good is just pure miracle. There's a lot of luck in this as well. So
the more you practice, the more lucky you get.
That's true.
That's what I've heard.
Yeah. But I mean, it's of course we calculate stuff, right? We calculate the wall thickness of the drum. We calculate the dimensions and all this to get the right. There should be some correct size for a batch of coffee, right? For that specific batch. So we do that stuff, but having it 100% tested and having 50 people test roast on it and cup on this machine, we didn't do that.
Yeah, and also you might at some point find out, that's why Probat gave up when they tried with but they never published it, right? But it might be that a lot of people have tried it before without publishing anything, and you would stumble into the same hole that they did, right?
Yeah.
How you wouldn't know, right?
You wouldn't know.
So that's really that's really fascinating. So what about things like in the drum? Is it called pedals? Or
yeah.
How do you go about thinking about shape, size, position?
Well, I was living in a very tiny apartment at the time, just because I basically had no job, right? I was doing this catalog photography every 2 months just to get some money into, so that I could eat basically. And I was sitting in this cafe every day with my big laptop and just doing the CAD and studying all these things. And he had a Probatino. So when he was out, I would go to the Probatino and just take out the trier. Actually, the trier of this is modeled off the Probatino, same size.
Okay.
And I would then look at how they designed the pedals for that machine, and I would take the same principle but manufacturing in a completely different way, because they have basically have one pedal moving the beats forward and then a smaller pedal moving it backwards.
Yeah.
But I integrated all of those into the same.
Because you need to have a good dynamics, and then when you open the door, it needs to get out pretty quickly, right? That's the problem you need to solve.
This we tested, of course, right? So we would do maybe 3 different drums with different angle of veins, and then we did some big batches to see that they're all consistent in the roast, and how well they come out as well. So of course, these are simple tests to do, and we did this, of course. But in terms of the actual taste, there were not that many tests. But it turned out that luckily, the quality and the cup that comes from the bullet is good. But that, I would say, is lucky.
But sometimes it's okay to be lucky.
Yeah, it is. Absolutely.
So if you look at your kind of roasting education, the way you understand what's going on with the beans. What has been your biggest inspirations over the years? Understanding what's actually going on with the beans and all that.
To be honest, I am not an expert roaster at all. But like for myself, I find people like you, like Rob Hoos, and other people in Taiwan who knows what they're doing when it comes to roasting. So I tried to educate myself to become a great roaster, but I thought that my skills lie more in designing products and solving these kind of problems.
I completely understand, but you know a bit about coffee roasting.
Oh, of course I do.
And that my question was kind of, what kind of have you had some kind of simple framework to think about the coffee roasting process to help you design it?
Yeah. Well, yes, because the sensors that we've made to the V2 bullet, the what we call IBTS, which is the infrared sensing of the coffee, is something that I wanted to have because I could not get, because I'm not an expert and I couldn't understand how you actually just use a trier to judge where you are in the process. So I wanted to look at data because I thought that would be better. So that's why we changed from being an infrared probe only for preheating the drum, which was the version 1, to actually having a infrared sensing technology looking at the beans while roasting and the drum while preheating. So it has two purposes, right? So I designed that because I wanted to be able to look at data, and also because I think coffee is interesting because you got all these pros and amateurs alike who all claim that they found the holy grail to coffee roasting, right? And the way they talk about coffee is in such a way that it sounds like it's scientific, but it's not. It's pseudoscience, right? And that's also why I really enjoy working with you, because
that's what I call bro science.
Exactly. But I think most of them are like that, right? Even you go to some cupping competition or like a roasting competition, when he's talking about how he did this roast, he'll be like sharing all these ideas about what he thinks is going on, but telling them like they're facts. And I'm like, one guy is saying one thing, the other guy is saying another thing. So I thought, let's try to develop the sensor that can actually look at like what is really happening in terms of the temperature of the beans, because traditional sensors, they lag anywhere between 2 to 5 minutes behind. So what you're reading is basically the temperature 2 minutes to 5 minutes ago. And that's why we did the IBTS, because it's more or less real time. It's only 5 to 7 seconds behind, because it has to do the computation to get rid of there are 3 veins inside the drum. And once you turn the drum, you're also looking at the vein.
Oh yeah.
So that will give you some wrong data. So we have to run it through a digital filter, and that takes these around 5 to 7 seconds to compute what is the actual bean temperature.
Okay.
But to me, that's what I wanted, because I thought that by looking at, let's say, the end temperature and then the time, let's say from first crack till the end, what is that time? And how much has the temperature risen from first crack till the end? That's how I roast coffee personally. And once you've done, like, let's say 1 or 2 roasts, you basically know exactly where that particular bean is gonna start cracking, right? So instead of listening to it, I just mark it at that temperature, and then I measure the time till the end, and then how many degrees of rise I have gone from that time.
Oh,
thanks a lot.
Thanks a lot.
Appreciate it. So that's how I go about roasting, just looking at the data, because I don't have the education to or the expertise to actually smell and use a trier, for example, to.
Yeah, but smelling I don't do anyway. The trier I just use to really match the color. So for me, I'm exactly like you. I just need the data, because those you can trust, and then you can do a lot of sensor analysis and then correlate to your data. But smelling something, there's too much variation on what, and even kind of noticing down yellow and cinnamon, I don't do it
because
it's not precise enough for me to ever want to make any decisions based on it. Yeah. So I know Rob is doing that, and I tested him when he was here. He's really consistent.
Yeah.
But so he is obviously trained enough for him to make the same decision every time he does. He sees the same. So it's possible, but I don't think it's good as a general recommendation, because it's so difficult to do anyway.
Yeah.
And you have the information in a sense already, because you know when first crack is, and you know how you treated the heat source. So you have that. So I'm always, if you have the information already, don't spend time collecting it. So I think from an education point of view, I don't think it's a good thing to recommend people to spend a lot of time training. It's possible, I've seen it, but it's not. I don't think it's recommended for beginners to. They should focus on something else. Yeah. Because you only have a limited amount of focus and energy, and you should spend it where it matters most. So, and I think this is so. I'm actually exactly like you. First, I really do the control, then I do diversity. I really need to understand the machine first. That's the control. Basically, that's the step on it and see what happens, right? Yeah. And then build the standard roast that that's a concept I've developed. And then I go to diversity, where I want to explore. And then I go to the cupping. Yeah. I don't mix them. And this is where people often, the curve has to look like this.
But that's also the scientific approach, right?
It is the scientific approach, where you distinguish between intensities and preferences and technicalities. And then you see how they correlate.
Exactly. Yeah.
So you cannot get an optimum shave curve, because then you are missing out on diversity. But for whom, right? Yeah. What if somebody likes the curves to look like that, right?
I mean, we had so much fun, because if you look at, I mean, there was this saying, or there's been this saying from the very beginning, that you should never stall your roast, right? You should always be going up in temperature. Yeah. But the fun thing is that when you look at once we started installing the IBTS, because we sold an upgrade kit so that anyone who had the roaster could actually upgrade to a V2, right, to get the IBTS sensor. We started to see that most of the roasts that people do have actually stalled already. If you look at the IBTS, but because the traditional probe is so behind, it keeps going up. But in reality, you have the other curve of the IBTS, and your temperature is actually going down. Yeah. And they say this is perfect. So all these myths about
thanks a lot.
The temperature having to keep rising is we saw that this is actually not true.
And that's also my point about this obsession about small details on graphs and things, because those details are artifact to some extent anyway, and might even miss something that's happening that you don't ever see. Yeah. So there's no reason to over obsess about really small things, because you're looking at artifacts, and then if you do the rate of rise thing, which is a derivative of an artifact, it's just you are just so far from the first principles of that you are losing completely intuition. And that's why I'm kind of stay with flame size, stay with seconds of temperature, stay with the first principles, because you're just digressing and making everybody very confused. So that's but I can hear, and that's also I've noticed that we have a very pretty similar approach to a lot of things, and that's. I also just want to talk a bit about the software, because that was another thing. So I remember when I was sitting there struggling with the 200 grams, I was just but I really like the software. I like the machine, like the software, and who knows about that? I had no idea about the flavor yet, right? But I was just really, this is a proper piece of software, man. It's really. Yeah. It's got everything. It's got a client, it's got a cloud, it's got all the features. And what I love is the recipe mode, because I think we talked about that before. That's how I do it anyway, right? You plan out something, you don't interfere, you see how your plan goes. And if you want to change, you change the next one. You don't improvise, you don't micromanage. Because if you are interfering, you're doing something that you should have done 2 minutes ago.
Yeah, it's too late anyway.
And it's too late anyway. Yeah. And you will never learn then, okay, was it 1.5 minutes deviation of your plan, or was it only 20 seconds? You'll never learn if you don't let it play all the way to the end. Yeah. So basically with I have these business cards, and when people are done with my courses, they have this stack of business cards. And basically it's the flame plan, And this, with the bullet, they'll just put in everything they have in the column. They will put in the row in the software, and it does exactly what I've done for now 16 years when I teach people. So how did this idea come up, rather than, for example, PID control or any other way you could have controlled the roast?
Well, PID doesn't work in coffee roasting. It's impossible, because you have such a massive amount of metal that is preheated, right? You are heating it up to a very high temperature first, and because it's so massive, any change that you make while roasting, it takes a long time before you can start reading that in your data. And especially with a traditional probe, like a bean probe sitting inside of the mass of the bean, I mean, you go from half power to your gas and to full. It takes a while before you start noticing anything happening. On the IBTS, of course, it's better, but it's PID. It requires that PID is great for having the same temperature stable over a longer period of time. It's great for that, but for something that is rising and something you want to control, you can't use PID for that.
But there are some roasters that are using the PID on the air temperature rather than the bean, and that solves the problems a bit.
Because air is different, because you would actually have a very high temperature from the beginning.
But also a quicker response.
Yeah, because it's just the air, right? So for air you can, but for air you would not change the temperature all the time. You would probably have, let's say you start by having let's say 200 degree air, for example, and then the beans will heat up slowly, and then once you get to a stage in your roasting, you can then change the temperature, and then the PID only have to stabilize the temperature of the air. So for that it works. But once you have a big mass of metal, you cannot use PID. So that's why for our goal, if you want consistency, first you need to know how much energy is stored in your drum, and that's what we use the IBTS sensor for. Because when there's no beans, it's just looking at the metal, right?
Yeah, and it's a pretty solid drum. It's 1 kilo, right? So it's pretty thick. So
I think it's like 4-6 kilos.
Okay.
The weight, you mean?
Yeah, it's really a heavy drum, right? Even heavier than I remember. So the energy that's stored is pretty much answered just by measuring the temperature of that single.
Yeah, exactly. Yeah. So once you have an accurate measurement of how hot your drum is, and if you can replicate that, then at least you can replicate the first part of your roast, right? Because once you drop in the coffee, the beans are going to absorb the energy from the drum. And if that is consistent, then that's step number one. Yeah. Second step is to be able to control the output of the heater. And that's a lot easier with induction than it is on a traditional heating element. Because heating element, you have to you superheat the air basically, and then the air will then heat up the drum. But air is also a great insulator.
So there's also some radiation, right?
Then there's radiation, but then it depends on what's the color of your drum, right? Because if you've got a very shiny steel drum, it's not going to absorb the radiation very well. So there's many factors in that. But for induction, we can actually measure the current being delivered through the coil.
It's funny because there's a lot of problems getting the heat to the beans, right, and to the drum. Yeah. So you deplete oxygen if you have a flame, then there's less oxygen. Yeah. I don't know if that's good or bad for the beans, but you have a lot of waste, right? Yeah. So much waste.
For sure.
And that's
but the beauty of induction is that your heating element is the drum itself. Yeah. Right? So you go from a magnetic field that just goes straight into your drum. Yeah. I think induction is great when you have something that is moving and you have a fixed heat source, and the distance is not too great. Yeah. Then induction is perfect, just like on a pan, right? Once you lift it off too far, it doesn't work anymore. Yeah. But you still want to be able to move the pan. So that's where induction is great. So for a roaster, it's actually.
And this is so consistency is important to be able to do the predicted flame thing. Yeah. Because and this is my point about roasters, that you need to be roasters, if built correctly, are extremely predictable. It's like playing Angry Birds. If you do something, you should get a certain result. So people micromanaging the flame kind of doesn't know the machine. Yeah. And that's my whole point. So that's why I have this control point where I have this standard roast that people with 3 flame settings. You need to be able to get first crack in 9 minutes, 3 minute development time to the midway point. For me, that's the speed blueprint I need to know of a roaster before feeling I have an intimate intuition with the roaster. So that's my first. And based on that, if it doesn't behave exactly as I want, then there's something I don't understand that I should understand to understand my roaster. And if people are micromanaging the flame to get a certain curve that they've heard somebody else, then that shows to me that there's a step they are missing. And this is so much obsession about following the curve has left so many people incompetent because they are missing the basic step. And this is where this is where, by coincidence, call it luck, that again, your software has this. Your software assumes that your technology is consistent, right? Yeah. That the drum actually, if you read a temperature, it represents an actual accumulated amount of energy, because if it didn't, you wouldn't be able to make these reductions and then get the same result. So you have put a lot of energy, emphasis on actually make it understanding the thermodynamics in the machine to the extent that you trust if you do the same, you get the same result. Otherwise, you would have had to do PID or other. So in that sense, there's a kind of a correlation between our approach to technology.
Sure. But this is also what we were able to prove. And this was super fun after we installed, because before I talked about the stalling, right, that we can measure that basically most roasts that are very flat at the end, they have stalled already. So that was one myth that we debunked right there. But the other thing was super interesting is that if you look at the traditional bean temperature probe, when you did your first, let's say you did a recipe in roast times, our software. So it's basically your approach, right? You set it to, based on time, you said, 1500 watts or P9 for 3 minutes. And then you go down to P8 and P7 or whatever, and you change the fan speed setting. So if you just did 3 roasts back to back, you would see that the first roast, traditionally, the bean probe temperature were lower, right? And this is probably what you've seen in big roasters as well. It's the same thing. They would say the first roast is...
you always get first crack 3 degrees lower than on the subsequent, right? Yeah.
And then the second one would be the baseline, and then the third one would be even higher, right? But once you install the IBTS, the IBTS temperature, they were spot on all 3 times. So people have been compensating, from the first and the second and the third to something that they never had to touch. If they just left it at the right setting, they would have gotten the exact same result. But they just because the inconsistency in the data from the shitty beam probe, which is, on ours is the same principle. All roasters that use the traditional beam probes, they suck. So, and it's probably something to do with the front plate, where the beam probe sits, also gets heated up, because they also absorb some of the heat from the probe itself, right? So they get heated up, and then they show a different temperature. But like you said, if your approach was just to look at power output and fan speed setting, you would have gotten the exact same roast all the time. Yeah. And we proved that with the IBTS as well, which was super fun.
It's pretty interesting, and that's also, I think, a kind of a hallmark of your approach, right? That like induction, that already existed, right? And everybody who's had these IRR guns, it's not expensive technology on you, but it's just not used. And then you're thinking, well, why don't we use an IRR? And then no, that's not done before. Nobody else do it. What do you think? Don't you think there are some problems using that you haven't just thought about? You're a photographer. What do you know about? And then you plug it in and it works perfectly. And even you had it already because you used it you just had to turn it.
You're right. We had it in the beginning, and we used a glass in front of the sensor called germanium. The material is germanium to protect the sensor from dust, right? So that piece of glass was just facing the drum, which also meant it had to be clean sometimes. Otherwise, you wouldn't get consistent preheating, because that's all it was used for. But then we came up with the idea of blowing air across the center to just protect it from all the dirt and dust and humidity from inside of the drum. So basically, we're blowing like a tiny amount of air into the drum just to protect it. I came up with this idea one day in the office. I thought, well, why not? I mean, this sounds so silly. So I sent one engineer down to the shop, bought a tiny 20 millimeter fan. I designed it in probably an hour. Then we 3D printed the part, modded because there's a silicon eye already. We just modded that and just glued it on, and it worked. But of course, you get all the shitty data, right? You would get all these artifacts, which you then have to develop the digital filter. That was
which is not a small thing.
That's something that is part of our proprietary firmware, right? Which is very, very advanced. Actually, it's actually so. It's using probably 2/3 of the processing power of the chip on the board just to get the right temperature. So because we don't want to just average, right? We want to have something.
You need to have a thresholding or something like a gate, isn't it called that almost? Like
you have to do an interview with Jacob. He will explain everything to you.
No, I don't know. I'm just talking.
But it's very advanced.
But it's funny because now we're talking about consistency. In December, I had Corona and I had a virtual bullet course. So I just took the bullet and drove to my friend's summer house where I could then conduct it. And I just wanted to know, out there I have a chimney on with a small suction, and I just wanted to check if it was consistent. So because here I had to put it on the stove and just use the hood in the kitchen, right? Sure. And then I did at my standard roast, so it's P9 until IPTS 150, and then I go to 7, and at 190 I go to 5, and then I get the midway point after 3 minutes. So I checked it in this new place, right? And I did it, and I think I got first crack at 8 minutes and 57 seconds, and I got 3 minute development time, and I measured Actron 55.1, and normally that's 55. It was just, I have to kind of get to know this roaster in the new, if anything changes in a few hours, have this course. I thought that I had to spend some time making sure that things behaved normally. I did the first roast, and it was just, 3 seconds off, and exactly the color. I was just, okay, I'm ready for the course. So they are really kind of tested this, and so I'm really, I'm really impressed with it.
But there are of course some variables, like for example your environmental temperature. If you're roasting in a very cold environment or very hot, there will be some differences, right?
But this was in a living room, and I have the same conditions out there. Of course it changes, but that's fair enough. It uses air from surroundings, so
exactly. But so that's also what we are trying to do on the new machine, the IO. We even these inconsistencies, we are trying to develop a machine that can take care of that by itself, right? So you could be roasting in 0 degrees outside or 35 or 40 in Saudi Arabia, and you should still get the same result. That's the end goal.
And that's the funny thing, because this is the feeling you get, and that's also when I use this for education. You get the same experience, right? In a drum roast, you still need to worry a bit about consistency. That's why there's a time between the roast, and you get all the you do manual. It's very manual in the sense that you're controlling the heat source directly, just like in any other roaster. So here, no automation. Well, you can. It's consistent, so you can do the same and you get the same result because it's consistent. But really, before you build all that, you are manually interfering just as any other production roaster. So people, they learn, it's the same iterative learning in order to control it that you need to go through with this. And that's why it's a great education roaster, because it's the same iterative thinking you have to do to understand the dynamics of the machine. So that's kind of a different paradigm as the new one you're building, where you basically, it's completely different, right? It's not kind of the handcraft approach in the same way.
Well, no, you don't have to, but you can still do that, of course.
Okay.
You can still do the artisan. You can do everything manually if you want. You can automate it from a computer. You can automate it directly from the machine. Our idea is that if you are, like for example, if you're an artist and you're painting a picture, but you want to sell some copies of your image, you're not going to paint the same thing again and again. Same thing for our roasting. Once you've developed your recipe for that particular bean, which you should develop by yourself, right, to your preference, and within that there is that artisan approach in developing your recipes. But after that, you should just let anyone, any barista, just weigh out the beans, put them in the funnel, and press start. That's the idea.
Yeah, and I think that's a brilliant idea. So as long as you can kind of still get the experience of doing things manually, and the machine will not think for you, just
for sure.
do whatever you told it to do,
and
then you can log it in once you are happy with your. So we'll see this in Milan.
Yes, it will be
also
Milan.
roasting.
Also roasting, yes.
Looking forward
Unless
to
something
that.
happened during the shipping, but I think it should be fine. Yeah.
Great.
It will not be roasting automatically. It will be roasting manually, but it will give you an idea about what it can do for sure.
Great.
Yeah.
So my last question is just I'm just curious if you could say a few things about how you see Coffee Mind as an entity in the whole this roasting thing and education, and is there something, because I have no idea what you kind of heard and experienced, so I'm just curious about if our approach, what has kind of struck you.
As you said, Morten, we have the same approach, right? We try to take a scientific approach to the roasting process, and that's also what we want to do. Like, I want to be able to create the tools. And by that, it's not just roasters, but also all the sensors, and finding out, what kind of new sensors should we develop so that we can get, consistent result. Because our end goal here is that we want every cafe to be roasting on Aillio, because you have massive savings, you have fresher, freshness, you have you save tons of money, you're saving the environment as well, because it's a green technology product. So that's what we want, right? We want to sell the machine to any kind of coffee shop that cares about their quality and the environment. And for this, our approach is also to look at it scientifically and find out what's really going on here, and how does our data translate to something, to a flavor in the cup. So that's the end goal for us, is that we look at all the data, and then let's say you have one guy in roasting in Copenhagen, one bean from Colombia, and then you have one guy in Medellin, one guy in Copenhagen roasting here, one guy in Colombia, Medellin, at 1,500 meters, different environment, different altitude. How can you get the same flavor in the cup? And what kind of technology do we need to develop to solve that issue? So again, it's getting more and more scientific, right?
Yeah.
And it's going more and more in the direction of taste and flavor. So, and I think that's what I love about you, is that you've done. I mean, you're the only one I know who's written all these scientific papers on coffee, and also just taking it back to the basics of how do people even taste. I think this is super interesting, right? Like, also something we discovered, like. Some people just prefer one type of flavor over another, and then how can we match that with the beans we are selling? And so this scientific approach is also because there's so much what did you call it before?
Bro science.
Bro science in this industry, right? So
bro science. It's when two bros are hanging out in the locker room after a hard workout,
out
and
the world,
talking about how the physiology and supplements and the whole.
Exactly. So
it's a pretty funny concept. So okay, but I think you also need to be somewhere soon.
I do.
So,
yes.
But I really appreciate you want to spend time doing this. Obviously, this is fun.
Absolutely, yeah.
And also, I want to thank you for all the hard work you've done to bring this to the community.
Likewise, Morten.
Well, yeah. But you created this. I'm sure that this is a lot of work. So I think it's amazing that you created this. But another thing, and that's also why I wanted to kind of zoom in a bit on this in the beginning, that you're also an inspiration in the entrepreneurial spirit, because that is, your clients are not manufacturers, but
No.
they are entrepreneurs, right?
Yeah.
So in that sense, you are really connecting well because you've done something that is on paper impossible, but you did it because you couldn't help yourself
Couldn't
doing
resist,
it and
yeah,
just
yeah.
keep on doing it.
Yeah.
And that's basically what we do in the coffee business, right?
Yeah. Keep exploring, yeah.
That's really also thank you for your spirit as well,
No
bringing all this to the community. So.
Thanks
Great, but see you in Milan.
Yeah, good to have you, Morten. See you in Milan.